Hello everyone, my name is Oliver Burry. I work at the Bioimaging and Optics platform at EPFL in Lausanne, Switzerland. And in this video, I want to show you all the steps that you need in order to install StarDist on a Windows 10 machine with GPU support. We have a public page that's available on a platform called C4Science that will summarize everything that we will be doing here today. If you'd like to find it, simply type C4Science and then Miniconda StarDist on Google, and you should be able to find it here under Miniconda setup. The reason for this video is that there is no A to Z tutorial on how to install this on a Windows 10 machine that actually works. So hopefully with this video, you'll be able to follow every step from a completely clean Windows 10 installation up to the point that you can run StarDist training on the example dataset that is provided. So let's get started. Let's talk about the requirements first. We're going to be installing Miniconda, which is a smaller version of Anaconda that can manage a lot of stuff for us already. However, in order to compile StarDist and make sure that we can use all the, let's say, accelerations that it makes use of, we're going to need a few other things. We're going to need to install the build tools for Visual Studio 2019, and we're going to need to install the NVIDIA CUDA Toolkit version 10.0. After that, there's going to be a little bit of work that needs to be done by setting up some environment variables within Windows 10. And finally, we can really run the installation of our StarDist with Conda. So let's start by installing Miniconda. You simply need to click on this link. It'll take you to the Miniconda installation page, and the one we need is Python 3.7 for Windows 64-bit. I have it already downloaded here, Miniconda 3. So for the purposes of this video, the parts where it is installing, I'm going to be accelerating it, but basically you are following me through the entire installation. So in our case, we're going to install this for all users because we have different people logging into this machine, and all these people are going to need to use Miniconda. Here we're installing it to the default location in C program data. We're registering it as the Python 3.7 because we do not have Python installed on this machine. However, we don't add it to the system environment variable. We don't need this, and it's apparently not recommended. Good, so the Anaconda installation is complete. We don't need to look at any of the documentation, and we're done. Step 2, we will download and install build tools for Visual Studio. So if you click on this link, it will take you to this page, and this is the one that we want. We do not need to install the entirety of Visual Studio, only the build tools. So when you download that, it'll download a small package. It's called VS Build Tools. Once you've got the installer installed and running, you should see something like this. You don't need to install any of the workloads. You simply need the individual components here. And what are those individual components? It's these two, Windows 10 SDK and MSVC 142. So Windows 10 SDK is down here. It's the last one. And if you can't find this complicated name, you can simply copy paste that into the search bar, and it'll give you a bunch of them. The one you need to find is the C++ x64-86 build tools, and the latest one is version 14.25. Great, so the installation of Visual Studio build tools finished, and we can close this. It could happen that for your computer it will require you to restart, so please do that before going to the next steps. The next step is to install NVIDIA CUDA version 10.0. So we can download the CUDA toolkit here. It's Windows 1064 for Windows 10. We download the executable, I already have it here. So here we simply agree. I would recommend that you use the custom mode because there's a lot of things we don't need to install. We don't need the physics component. If you have an up-to-date NVIDIA driver, then you really don't need this. And you don't need GeForce Experience. You only need the runtime and the development. Hit next. This will be installed in the default location in C program files. NVIDIA finished installing. You simply need to close this. Again, if you are needed to restart your computer, please do so before going to the next step. Now every prerequisite has been installed, but there's still a little bit of setup that we need to go through, which is to set up these environment variables, which unfortunately are not set for us, and it will cause you an error when we try to install this Python package called PyOpenCL. So to do this, we search on the Windows toolbar for environment variables. And this takes you here to System Properties, and here you find environment variables. When you click, you see that it's generated the CUDA path version 10, and we need to create these two, include and lib. So I'm going to hit new, include, and here I will browse to this location. So in my case, it's in program files, NVIDIA GPU Computing CUDA version 10/include. So we hit browse directory. This computer, system, program files, NVIDIA GPU version 10 include. So now that is done. We have it here. And we create a new one called lib. And we search for roughly the same place, except that instead of version 10.0 include, it'll be 10.0 lib x64. Make sure you change this if you changed the default install location for the NVIDIA CUDA. Then you hit OK, and we're ready now to start installing the StarDist environment. Now we can install our StarDist Conda environment. In order to do that, we've provided you with a biop-deep.yml file, which you can download here. We'll open it and have a look. It sort of tries to simplify the issues that we've had installing StarDist with gputools support. So basically what this does is it will install pip, which we need to handle packages. It'll install the right version of Python. And very importantly, it will install TensorFlow version for the GPU, 1.14. And this weird message here says that basically this version is actually handled by Anaconda, and it's not the default TensorFlow GPU you would download if you weren't doing it this way. We also install IPy widgets and Jupyter Lab and Node.js in order to be able to use Jupyter Lab with StarDist and have a lot of little widgets in case we like to make the Jupyter notebooks interactive. These two here are not necessary, but we include them. And now here comes the really important part. To get gputools to work, you need PyOpenCL, which needs PyBind 11. And basically, you need to install them in this order specifically. And as StarDist is, of course, not managed by Anaconda, it's being installed via pip, which is the Python installer program. So we will put these in exactly in this order. First, it'll install PyBind, and then PyOpenCL, then gputools, and then StarDist. Now let's run the installation of our Conda environment. So for those of you who don't know, Conda, Anaconda, Miniconda, they're all the same thing. They are a tool that allows you to have different versions of many different libraries and different tools that are managed in such a way that they can coexist. Because you're downloading something from, let's say, one publication that is running on an older version of some underground library, and then you want to install something new, and by installing something new, it would break your other installs. So Anaconda is nothing but what's called a package manager and an environment manager. It makes sure that if you want to run StarDist, it'll run with the right versions of all the right tools. And if you run some other tool that needs different versions, then you would need to create another Conda environment for it, and nothing will break your StarDist installation. To create our Anaconda StarDist environment, we need to start the Anaconda prompt. So if you would type the Windows key and you start typing Anaconda, you will find it. It looks like this, Anaconda prompt. And here we're going to create, so conda is the command, environment create, and we're going to give it the folder where we want to install this environment. This is a little bit different than what you would see in the very default conda environment create, where you simply specify the name. And the reason we don't do that is because we don't want this conda environment, which is going to be relatively big, maybe 1 GB or 2, to sit on the same disk as C. Because if you start having multiple users using Anaconda, each environment is going to be a few gigabytes, and it's going to start getting bigger and bigger, and you might overwhelm your C drive. So we make sure that we install things on another disk. In this case, it will be installed on the D drive, which has a much higher capacity. And in case this drive gets full, there's no problem with Windows. So we need two things. We need the path that we want to create the folder at, and we need the path to this biopdeep.yml file. So let's start typing. So for the sake of this example, I'm calling my environment stardist-env, and it is going to reside in my D drive. And now here, F, this will define the file for the biopdeep. And in Windows, you can do something very easy. If you have it downloaded somewhere, simply drag and drop it into the command line, and then it will add the entire thing. When you hit enter, it will run the entire installation for us. Hopefully, thanks to all the preliminary work we've done, this is what you should see at the end of everything. So to activate the environment, we need to use conda activate, and you see that it's not just the name, but the full path that we need to give it. So if I would do that, I could go to conda activate d/. And then you see here in parentheses, this explains to us that StarDist is currently, this environment is currently active and has all of StarDist and Jupyter running. So now that we've installed our conda environment, we're going to be testing our installation. So to do that, we go to the StarDist repository on GitHub, which is here. And at the right corner, we are going to do clone or download, download zip. This will provide us with a zip file that I've already downloaded here, called stardistmaster.zip, which I've unzipped into this folder. This will contain the example notebooks that we want to be using. You notice I unzipped it here on my desktop, but you're free to unzip this in a more permanent location. So we can move to my StarDist installation. So I can CD there, and there I can go to StarDist master. From here now, I can finally start Jupyter Lab. And if everything worked well, we should automatically be sent to the currently open Jupyter Lab, which looks like this. And because we are already in the StarDist master folder, we can browse and find the examples. So you double click on this, and we're going to be running each of these cells one by one. So this is the part that will take a while. We'll download the files from the Data Science Bowl 2018. And we can run the rest simply to make sure that nothing is hanging up. Then here, we've reached the end of the notebook with the examples, and this has been executed now on your local machine and seems to work perfectly. Now that we have the data, we can finally test the training, which is the goal of everything we've done so far. So when you run this notebook, you should get the message that you're using the TensorFlow backend. Here, it's simply complaining about some future warnings. You can safely ignore these, don't worry about it. We downloaded the data set in the previous step, so normally we're able to load the data here. We can read them out, normalize them, split them, and visualize them. Now, here comes the important part. So we are setting up the configuration, and because we have worked out a way to use the OpenCL-based computation, which requires the GPU tools, which have been installed, we can set this to true, and you can do your first test. So when you run this cell and you look at the configuration, you should find down here the use GPU should be set to true. If you get that, you're pretty much done, because it means that you wanted to use the GPU and that StarDist determined that GPU tools was available for your computer. I'm going to skip this one because on Windows it gives an error. I don't need particularly to limit the memory of my GPU, but it does complain about TensorFlow, so this might be a version problem. We create our model. We keep running this. We define this is the most recent Jupyter notebook of StarDist, and you see that it includes data augmentation with flips and rotation and intensity changes. And we can set it to quick demo simply to see that this is working properly. And if it does, we should be able to see the epochs advancing exactly the way we would want. Epoch 1 out of 2. It's run very fast, 3 seconds. Epoch 2 out of 2, it's ran even faster, and it's done. Similarly, if you want to make sure that you're using your GPU, you can go on your Miniconda prompt, and you should find a line that says something like this. Create a TensorFlow device, GPU 0 with 6.2 gigabytes of memory. In my case, it's a GeForce GTX 1080 with a compute capability of 6.1. So if you find this line, then it clearly means that it found the GPUs. So let's test whether what we've done with the use GPU was worth it. So let's set it to false. And train a StarDist model called no GPU tools. And we also set here quick demo to false. It was 35 seconds here for the first epoch. And for the second epoch apparently about 32 seconds. All right, let's stop this. So now we're going to do the same thing again, but we're going to set GPU to true and see how long that takes. So here I've called it StarDist GPU tools. And quick demo set to false again in order to see the time it actually takes. I think you can appreciate that there was, or it seems like there was, a nice substantial gain in speed. Let's see on the second epoch. So we've gone from 35 seconds to 15 seconds. And for the second epoch, now that we're fully working, we are at 10 seconds. So we've roughly, for this data set, we've increased the speed for training by about a factor of 3. So quite worth it. So that's it for me. Thank you for your time. This hopefully will be useful for anyone else who's been having trouble installing TensorFlow for StarDist using GPU tools. Everything I've shown you is summarized in this short page here, which you can download from C4Science if you search for TensorFlow GPU or Miniconda on Google, like I showed you at the beginning of the video. If you have any questions, don't hesitate to go to the ImageSC forum. And you can find tags for StarDist. And here is the desired place where you can really send all your questions, double check, and get help for training your models. And if you have any questions, I will be available on this forum as well as Martin Weigert and Uwe Schmidt, the co-creators of StarDist. Thank you very much for your time. I hope this was useful to you. Goodbye.